Hello everyone. Today in this video, the integration of OpenDaylight VTN project with Microsoft SCVMM will be demonstrated. VTN project has two major modules. The first one is VTN Manager. It implements the VTN functionality in the OpenDaylight controller. The second one is VTN Coordinator. It is a multi-controller orchestration application which is a part of the orchestration layer in the SDN architecture. Microsoft System Center Virtual Machine Management is Microsoft Virtual Machine Support Center for Windows-based systems. It is a management solution for the virtualized data center. VSEM Provider is a plugin to bridge between Microsoft SCVMM and OpenDaylight controller. Microsoft Hyper-V is a server virtualization developed by Microsoft which provides virtualization services through hypervisor-based emulations. The first feature that will be demonstrated in this video is OpenDaylight VTN as network service provider for SCVMM. The second feature is network isolation using VTN. The software and tools required for this demonstration are Microsoft SCVMM server that is running with VSEM Provider for OpenDaylight installed and configured, a Windows server that has the Hyper-V enabled and configured as a cluster. In each of the Hyper-V, PF1000 virtual switch has been installed, which provides the OpenFlow capability. A server running with ODL, which is Helium edition, with VTM enabled, and a Linux server that is running the VTN Coordinator. Next, we move on to the topology used in this demo. A SCVMM server with VSM Provider installed, a running VTN Coordinator, an ODL controller with VTN feature enabled. PF1000 has been installed in the two Hyper-V servers as it implements the OpenFlow capability in the Hyper-V. 3 OpenFlow switches simulated using Mininet and connected to a Hyper-V. And we have 4 VMs hosted using SCVMM. When the virtual switch is created on the Hyper-V in SCVMM console, it will be learned in the ODL controller. Then, on the creation of the VM network in the SCVMM, VTN will be created on the VTN Coordinator and ODL controller. Similarly, when subnetwork is created, vBridge will be created in the Coordinator and ODL. On the creation of the VM, the VLAN will be configured in the VTN. The first demo scenario, adding OpenDaylight VTN as network service, will be demonstrated now. For this, we move on to the first step of the addition of network service. For this, we right-click the network service and click on the Add Network Service option. Then we enter the name as VTN Server. Here we select the ODL manufacturer and ODL VSM provider as the model. In the Run User, we click the Browse button and then choose the VTN CO. Now we enter the connection string, which consists of the host name of the VTN Coordinator, then the port with which it interacts, and the IP of the ODL controller. Then select the ODL VSM provider as the configuration provider and check if the test connection has passed. We then now apply it to all the Hyper-V hosts. Now we can see the ODL is added as a network service. We now move on to the addition of port profile. A port profile enables VMM to set up a consistent set of capabilities for all hosts in a cluster rather than configuring each individually. For this, we right-click the port profiles and then select Create Hyper-V Port Profile. We enter the name as VMNIC Profile. We now check the option Allow Max Spoofing and click on the Next button. Here we are done with the port profile creation now. Next, we move on to the logical switch creation. Logical switch is a virtual switch connecting one or more virtual adapters to a logical network. For this, we right-click the logical switches and select the Create Logical Switch. Now we enter the name of the logical switch as tenant G01. Then enable the ODL virtual switch extension for the OpenFlow capability. In the uplink settings, select the team option. Then in the virtual port settings, click the add button to select the port classification as high bandwidth and enable ODL virtual switch extension and virtual network adapter settings. Now we are done with the logical switch creation. Next we move on to the registration of VLAN ID. The VLAN ID to be assigned to the subnetwork that is drawn from the VLAN ID range we created beforehand and automatically configured on the coordinator. The VLAN ID is now registered in the PowerShell before creating the VM network. For this, a commandlet has been developed in the VSEM Provider where the VM network and the subnetwork name is mentioned along with the coordinator name. Also, the VLAN ID's range of 300 through 399 is registered using the PowerShell. Next, we move on to the creation of VM networks and subnetworks. VM networks are defined by the logical networks, and the VMs created in the VMM establish the connectivity in VM network and the subnetworks. We right-click the VM network and select Create VM Network. We enter the name and we choose the default service for the logical network. Then we select the user-defined isolation. We then have to add the subnet name and the subnet IP address, which we choose to be 192.168.137.0/24. When the subnet is added, the VLAN ID is automatically configured on the coordinator. Similarly, we add another VM network as tenant AA2 and a subnetwork SUB2 with 192.168.130.0/24 as IP for the VM network. Next, we move on to the creation of list of IP addresses in a static pool for the VMs. The static IP address pool is created to associate with the VM subnetwork. For this, we right-click the VM network and click Create Static IP Address Pool. Then we enter the name and select the VM subnetwork to associate with the IP address pool. We have chosen to add 10 addresses to it. Now, the IP static pool is assigned to the VM subnetwork. Similarly, we can create another static pool for the second subnetwork SUB2. Here also, we assign 10 addresses to it. A failover cluster is created with the Hyper-V H1 and H2. In each of these hosts, virtual switch has to be created. For this, we right-click the H1 and select Properties. Then click the new logical switch and add tenant G01 logical switch that has been created earlier and add the network adapter to the logical switch. Similarly, we follow the same procedure for the host 2. Next is the creation of virtual machine. We select the virtual machine and select the template from the library. We enter the virtual machine name as host 1 at 192.168.137.1. We check the Hyper-V icon for the compatibility. Now in the hardware section, we select the subnet that was created and choose the classification as high bandwidth. We then click Next and choose the destination host on which the VM has to be created. Now that we have initiated the VM creation on H1, we can see the VM creation is in progress. The VM is now created in H1. We right-click the VM and turn on the VM. Then we select the Connect via console option to log into the VM. Now we open the command prompt to view the IP address assigned for this VM. The created VMs will have the IP address assigned automatically within the specified IP range that we had mentioned earlier while creating the subnetwork SUB1. Similarly, we have to create 3 other VMs, 2 in H2 and the other in H1. Here we have the host 1 and host 2 VMs created in H1, then host 3 and host 4 in H2. The VMs that was created in the Hyper-Vs H1 and H2 as read by the ODL controller is shown in the ODL GUI. The second demonstration is the network isolation using VTN. For this, we have the command prompt of the host 1 and host 3 are shown here. From the host 1, host 3 is pinged, which is present in the Hyper-V H2. It can be seen that the ping is successful from host 1 to host 3 as both these VMs are connected to the same subnet 1. On the left, we have the image showing the packet streaming to host 3 is successful. Now the host 4 is pinged from host 1. It can be seen that the ping to host 4 fails as this VM is present in a different subnetwork. In the left image, it can be seen that the packet streaming to host 4 is failed. Then from host 4, host 2 is pinged. It can be seen that the ping is successful to the host 2 as both the VMs belong to the subnetwork SUB2. As these two VMs are present in the same subnetwork. In the left side image, the packets are streamed from host 2 from host 4. Thank you for watching this video.